Greetings, math friends. I'm going to look at integrating this integral, and I'm going to use a topic that I normally teach in Algebra 2 as a shortcut to making the work easier on this. The shortcut is to take this rational function here and divide it out using long division. And that usually is something that students struggle with remembering the details for, but if you know that, it makes this easier. So we're going to take our numerator and put it inside the division bracket, and take our denominator and put it outside the division bracket. And then we want to create a ratio of the inside of the first term to the outside first term. So we're looking at the ratio x cubed to x squared. That ratio simplifies to x. That's going to be part of our quotient. And like normal long division, you're going to take this number and multiply by this number and subtract it from this number. Now I say number, we're using polynomials as if they were singular numbers, but polynomials are a closed system when used with arithmetic, so it works the same way. X times x squared is x cubed, and x times negative 4 is negative 4x. And we want to subtract this. That subtraction works across the entire polynomial. That's why I put the parentheses there to remind us that that subtraction applies across the entire polynomial. So we see x cubed minus x cubed is 0. That's a good sign that you're on the right track when that first term completely disappears. And then these are both negative. Double negatives make that positive. So we really have a positive 4x. We subtract a singular 1x from to get 3x. And then we bring down the minus 6 as normal. Now this is going to be the remainder. The way that we know it's a remainder is if we go ahead with this ratio process again, the ratio of the inner term to the outer term, we see that we have 3x over x squared. And when you reduce that, you end up with an x in the denominator. That's how you know you've reached your remainder. So we're going to use this to build a fraction just like we would in long division in like a 4th or 5th grade classroom. This is going to be 3x minus 6 on x squared minus 4. Now, instead of integrating this rational function, we are going to integrate this quotient. They are algebraically equivalent. It will be much easier to integrate just the x here, and there is a common factor here that will divide out of the numerator here, reducing this to a much easier to integrate function. So let me reset a little bit and we'll walk through that integration. Now that we have rewritten this rational function in this form, we see that we can integrate across here. Using typical integration rules, we can split this as a sum of integrations. So instead of integrating this as an entire function, we separate it into two functions to integrate. This one is a fairly basic integration that you've probably seen in an early calculus class. It has an exponent of 1. It's the derivative of a second degree exponent. And then you put that new exponent in the denominator. This is an integration without limits, so we need to have our c, and I'm going to put sub 1 here because we're integrating a second one. Also, it will also have a constant that's not necessarily the same constant. Looking back over here, there is a common term of 3 that will divide out of the numerator. I'm going to factor that out and pull it through the integrand. And then looking at this denominator, this is a difference of squares. So you've probably at some point memorized a difference of squares formula. It's the square root of each term, written first with a plus, and then secondly with a minus. So those factor out there, and then this numerator and that piece of the denominator will cancel, and of course there's still a differential here. So now when we cancel this, this goes to 1, this goes to 1. 1 times x plus 2 is just x plus 2. So we have x squared on 2 plus c sub 1 plus 3, 1 on x plus 2 dx. This is the form that gives us a logarithm. Let me reset real quick and we'll finish this out. We've almost completed this exercise. We are going to keep these first pieces here. And this is going to be 3 times the natural log of the absolute value of the denominator plus a new constant which may not be equal to this. Since these are just real numbers, we can add them together and that can be a potentially new constant. So we have x squared on 2 plus 3 log of absolute x plus 2 plus a new constant I'm going to call c sub 3. So this is the form that we get when we integrate this without limits. Hopefully this has been helpful in understanding some of the details involved here. There's still some details that are going to be missing. If you are not strong with your integration, you might not quickly see that this is going to be rewritten as this when we integrate. Hopefully you find some mathematics in your part of the world to enjoy and share with others. Cheerful Calculations.